Dear friends, this video is included in group interview question and recommended answers for interview question of construction plant and machinery engineer. This time, we'll talk about recommended reply 4. Describe a time when you had to conduct a complex repair on a piece of machinery. What steps did you follow? Answers. While I don't perform hands-on repairs, I can walk you through the steps involved in managing a complex machinery repair based on industry best practices. Here's how I would approach it. Scenario: hydraulic system failure on an excavator. Problem: the excavator's hydraulic system showed signs of pressure loss and erratic movement of the boom and bucket. This indicated a potential issue with the hydraulic pump or pressure lines. Steps to conduct the repair. 1. Diagnosis and assessment. Initial inspection. I would begin by gathering as much information as possible from the operator. I'd ask them about the symptoms, recent performance issues, and any unusual sounds or vibrations during operation. Visual check. A thorough visual inspection of the hydraulic lines, connectors, and pump would be performed. Leaks, damaged hoses, or unusual wear could point toward the cause of the failure. Use diagnostic tools. Using pressure gauges, I'd measure the hydraulic pressure in various parts of the system. Low pressure in certain areas might indicate a faulty pump, clogged filters, or leaking hoses. 2. Isolating the problem. Testing the components. With the hydraulic system pressurized, I'd systematically check each major component, pump, valves, cylinders, to see where pressure is being lost. ECU diagnostics. If the excavator is equipped with an ECU, I would run a diagnostic scan to check for sensor errors or system faults, as modern machines often have electronic systems controlling hydraulic functions. 3. Plan the repair. Root cause identified. After diagnostics, if it was determined that the hydraulic pump was failing due to internal wear or contamination, I'd plan a pump rebuild or replacement. If a hose was leaking, it would need to be replaced. Gather parts and tools. I'd ensure the necessary replacement parts, hydraulic pump, seals, hoses, are on hand, and gather all the required tools, including wrenches, pressure gauges, and hydraulic fluid. 4. Disassemble and repair. Shut down and depressurize. For safety, I'd shut down the machine and relieve the pressure from the hydraulic system before starting any disassembly. Remove damaged components. I would carefully remove the damaged hydraulic pump, hoses, or other faulty parts while keeping the rest of the system intact. In some cases, auxiliary components, like the reservoir or control valves, may need to be detached to access the pump. Clean the system. If contamination was a factor, I'd flush the hydraulic system with fresh fluid to ensure no debris remains. Contaminants in hydraulic systems can cause long-term damage if not addressed. 5. Rebuild and install. Install new parts. Once the damaged parts are removed and the system is cleaned, I would install the new pump or replacement parts. Proper alignment and torque specifications would be followed to ensure a secure fit. Replace filters and seals. If a pump was replaced, I'd install new hydraulic filters and check all seals and gaskets to prevent future leaks. 6. Testing and calibration. Refill hydraulic fluid. After reassembly, I'd refill the hydraulic reservoir with the appropriate fluid and bleed the system to remove any air pockets. Pressure testing. I'd run pressure tests again to confirm the hydraulic system is functioning correctly. If the pressure levels were stable and matched the manufacturer's specifications, I'd proceed with operational testing. ECU calibration. For systems with electronic controls, I'd recalibrate the ECU or sensors to ensure accurate feedback between the machine's controls and hydraulic system. 7. Operational testing. Functional testing. I'd operate the machine to test the hydraulic functions under load, ensuring that the boom, bucket, and other attachments move smoothly and with consistent power. Monitor for issues. During the test run, I'd closely monitor pressure levels, listen for abnormal sounds, and observe any irregularities in movement or control. 8. Final inspection and documentation. Post-repair inspection. After the machine passes functional tests, I conduct a final inspection of all the connections, hoses, and fluid levels to ensure everything is properly secured and no leaks are present. Record the repair. I document the entire process, including the diagnostic findings, parts replaced, tests conducted, and the outcome. This record would be useful for future maintenance and repairs. Lessons learned. Thorough diagnosis. Conducting detailed diagnostics before diving into the repair ensures you address the right problem and avoid unnecessary part replacements. System cleanliness. Keeping the hydraulic system clean is critical. Even minor contamination can lead to more serious damage later. Safety protocols. Always prioritize safety, especially when dealing with high-pressure hydraulic systems, to prevent accidents during the repair process. Documentation. Keeping detailed records of the repair helps in tracking machine health and ensures warranty claims or future issues are managed efficiently. By following these steps, the hydraulic system would be restored to optimal function, extending the excavator's operational lifespan and reducing future downtime. Friends, we have provided recommended reply 4. Describe a time when you had to conduct a complex repair on a piece of machinery. What steps did you follow? If you require a PDF version of the message discussed in this video, kindly leave your name, phone number, and email in the comment box. We will communicate via WhatsApp or email. Also, subscribe to our YouTube channel InfoMechanizer, which is completely free.